Hello, hello, hello. Hope you've had a good time working on the questions I set up for week one. And let's just let's have this conversation now and see how you got on. What might have presented issues, things that you need to work on. Might be quick fixes based on what I do in the video. If not, remember you can pop a comment or so, and once I get an understanding of where the struggles are, then I could look at putting up some more content to help with those. So, right, the first one, it starts off with completing the square. Yeah. So all of this in the GCSE curriculum, it's this the what we're looking at are the topics from GCSE that are going to carry over really. So completing the square was the first part we had to work on, and then interpreting it after, and then the length of a line. Let's see for part A. First bit to set up, you would have set up, or you should have set up the x minus 4 in bracket squared y4, because we always go with half of the coefficient of x, the b value. Remember, ax squared plus bx plus c. Okay, so we're going with that, and then you want to see, well, that square, that perfect square, x minus 4 by x minus 4, what is that going to give me, and what adjustment do I need to make to it? What do I need to add or take away from that to get the plus 19? Because we know we'll get the x squared minus 8x. Let's see. When we multiply that double bracket, so you do your scrap work, I call it, we'll get x squared minus 8x, that's plus 16, that's good. But wait a minute, we wanted to get x squared minus 8x plus 19, not plus 16, so we're 3 short. What do we need to do? We need to add a 3, and that's your final format. The value of A becoming the minus 4, the value of B becoming the positive 3. That's what you want to put on your answer line. Your square, your x minus 4 squared, plus the adjustment, which is a plus 3 to get that 19. So that's what we're looking at there. Looking for B. Hopefully you had success in that. If not, pop a message in the chat. Listen, this is your education. Doesn't matter if other people got it right. You need to let me know what you need help with. What do I need to focus more on? That's the idea. Moving on to B, sketching. This is a bit new, different, but just building on what you know already. What do we need? We need to sketch this graph. It's a quadratic graph. And they're giving us these points where it cuts the y-axis to the y-intercept, and also the minimum point, which, as you should recall, hopefully you'll recall, we can get the minimum point quickly from the completing the square form of f of x of y. Okay, so that value of q. Right, so let's see. We're going to sketch that graph, and the first thing, it's a quadratic, and I've made the u shape not an upside down u. Do you remember why? Yeah, that's right. It's because the coefficient, the number in front of x squared, is positive. It's a positive 1, and if it's positive, you'll have a minimum value. I mean, they said it's a minimum point as well. So on the basis of that, it's going to be a U shape. We can set up our axes, and now the question is, that graph, where are we going to put it on this U shape? That's what we have to be thinking about now. And that's where these 2 points, we want to plot P. We want to plot Q on the graph and then draw our curve so that it goes through P. It cuts the y-axis at the y-intercept through P, and then it goes down to Q wherever Q might be and goes back up. So Q has to be down here, but we want it in roughly the right position on your sketch. That's what you're going to get marks for the shape of the graph, but also going through that P and that Q sketched. Now P is a y-intercept, so it's the value when x is 0. And by the way, if any of these calculations, anything I'm saying you didn't do as yet, use the power of the pause. The power of the pause. Just pause me, work on the question based on the ideas I've given, maybe an aha moment you've had, and then you check what you've done on what I go on to do. Is it the same thing? Yeah, so use the power of the pause so that as far as possible, as much of the work is done by you, not just watching me, okay? So I do the substitution into y, into the original equation, f of x, okay, y. The y value is the function when we apply the function of x, yeah, so y is the output. So I set it up, I put in y, x is equal to 0, and that means we're left with 0. So p is 19, sorry, we're left with 19. So p is the point 0, 19. we want to put that on the graph, don't we? So P019, and we'll put it there. Now, no, you could put it anywhere on the graph. It's a sketch. We're not trying to draw things accurately. Not supposed to be drawn accurately, but we should have those key indicators. So the proportion could be totally messed up. It's fine. I just need to know, hey, it's cutting the axis at 0.19. That's what's going to be clear here. What actually is that 19? Doesn't matter. We don't need a scale. It's a sketch. You don't skip with an accurate scale. Now for Q, minimum point, we're going to set, how do you get the minimum of the graph? What's the smallest value that y can be, that we can get from the f of x function? It's when this bracket is 0. Do you remember why? Exactly, it's because, well, if we say this is a square number. So whatever you put in x, whether x is positive or negative, the smallest this bracket, this square is ever going to be is 0. It's never going to be negative. So the smallest, this number can be 0, and we're adding something to it. So overall, the smallest value you're going to get is the 3. So 3 is the minimum y coordinate, and that will happen when x is 4. If I set x is 4, I'm going to get that 0. So I'm not adding into 3. So 3 is the point, the point of Q. And this is what I meant about setting the bracket equals to 0 to get the minimum point. And we can put it, yeah, I'm going to put 4, 3 there, and you might be thinking, that's 4, that's not, sorry, this is 3 on the y-axis, and that's 19. No way, doesn't matter. It's a sketch. And the critical thing now to finish up the job, once you work out those 2 points and you put them roughly where they should be on a graph, is to get that curve, draw the smooth curve in. So I'll put the curve in there, and I'll delete the original idea that I had. And this is what we're looking for. I'm looking for that curve, I'm looking for the shape, and we're looking for it cutting the y-axis at 0.19, clearly labeled 0.19, and the minimum point, so the turning point, going down to Q43 and going up. The last bit, the last bit I'll comment on this is the idea for you to recall that what does this mean for the quadratic? It means that it has no solution. Did that come to your mind? These are the kind of things you got to be thinking about. And it has no solution because it's never cutting the x-axis. When we solve equals 0, it's where it cuts the x-axis. But this is never going to touch the x-axis. The minimum point is 4.3, so there is no solution. Or if you looked at solving with this was set equals to 0, what's going to happen? That plus 3 is going to go on the other side and become minus 3. Can't square root of negative numbers. There is no solution in the number system that we're working in. In further maths, we'll look at solutions with something called complex numbers, but don't need to go there. So that's B for you. And now for C. Let's finish up the job with part C. And what we're going to go here. We want to find the distance PQ. So from this point down to that point, and let's just visualize it. We got to 0.19. I'm doing a sketch. Again, it doesn't have to be done perfectly. You can see how I'm setting it up down here. The 4.3, and that's the line. We want the length of that line, the line joining P to Q. Pythagoras. Just think, you see, we don't think about diagonal, we think about vertical and horizontal. So actually think, well, if I started up here at P and I went down level with Q, what would be the height of the triangle? If I started at the horizontal for P, so we're actually 0, and I went all the way to 4, 0 to 4, what's the length? It's 4 down there. Yeah, it's 4. And here it's 19 take away 3. It's 16. So this is a 16 by 4 triangle. And using Pythagoras, you can find the length of the line. That's what you're looking for. That's how you find the distance between 2 points. It's an application of Pythagoras. That's what it's going to look like when you set it up. And I didn't say, but you get to use the, oh yeah, right, I know how to do it. Pause the video and you do your thing. That's what we're looking for. And you would put that whole thing into your calculator and solve, and you should get 4 root 17. 4 root 17 is what you're looking for CN, and that's your simplified surd. Okay, and you don't need to show any additional working. This is sufficient. You're showing the technique you're using, and let the calculator do its job. I don't need to see 16 squared. I don't need to see 4 squared. Just set up your model, put it into the calculator, and you're good to go. Okay. Any questions, comments on this particular question? Just pop it in the chat. I'm going to move on now to number 2. Let's go again. Number 2 now. Number 2. And we're not quite there. What happened there? Okay, yeah, right. We're at number 2. And number 2a, we go to indices. Indices. Not what you're used to in GCSEs, but hopefully you can make sense, or you will make sense of it. Okay, so they've told us we want to do a substitution, and this is a technique that's going to be really useful in algebra. Solving this equation in its original form to find solving is to find the value of x. Hint, hint. For part B, did you find the value of x? If not, go and sort out your part B. If you think you got it with y values, you're wrong, because we're solving for x. But the thing is, to solve for x in the current form is actually quite tricky. So you do a substitution for y using the y equals 2 to the power of x. You can get the values for y quickly, and then, well, because we know y is 2 to the power x, we can use y to get x. So that's a technique, substituting and solving. That's a technique you'll use extensively in advanced level maths. We said let's y be 2 to the power x. So let's see, we got to explore that 2 to the power 2x plus 1. Let's explore our knowledge of indices. And you got to remember, well, we're going backwards. For multiplication, we add the powers. So if you had a 2x plus 1, that came from a 2 to the power 2x being multiplied by a 2 to the power of 1. Because if I show you it like the version on the right-hand side for multiplication, you'll add the powers up. So you'll do 2x plus 1. So we're going backwards now. Do you think you can finish the job and show how we get 2y squared from there? Got to go a bit further. It's all about using the rules of indices, but doing it in reverse. That's what we're looking at here. Okay, so the next line, I'll focus on that 2 to the power 2x times 2 to the power 1. And, well, we don't need the multiplication sign. We don't need it at all. 2 to the power 1 is just 2, and it's being multiplied by 2 to the power 2x. So we can write it like that. And now you can start, hopefully you can start seeing what's going on. No, we need 2y squared. You can see the 2, this is y squared, but y is 2 to the power x. Rules of indices for brackets. Multiply. So that means I actually have 2. I can write it as 2 to the power of x. That's y squared, because if in brackets, you would multiply 2x to the power 2 is the same thing as 2 to the power x multiplied by 2. Brilliant, isn't it? Some nice fun there. Hopefully that makes sense. And from there, if y is 2 to the power x, then we can write it as 2y squared. And if that's 2y squared, now we can go that whole equation. We can see we've just changed the 2 to the power 2x plus 1 to 2y squared. So we have that there. And then take away 17, 2 to the power x. Well, 2 to the power x is y. So I have take away 17y plus 8. And that is how we show that the original equation in terms of x can be written in terms of y using that substitution. Y is 2 to the power of x. So that's part A. Part B now. We got to solve. Let's make some space here, part B, and we'll write it in terms of y. See, hence solve, and they gave us the original equation, but I'm just going to jump in. Well, that's the same as 2y squared minus 17y plus 8 if y is 2 to the power of x. So I'll solve my equation in terms of y. If you didn't solve it as yet, off you go. Solve it, get your y values, and then use your y values to get your x values, because y is 2 to the power of x. So once you know what y is, you can find what x is. That's the idea here. I've made a note here. FX991EX, Casio. I didn't write it as a Casio. If you don't have one, you got to get one. That is the calculator. That is the minimum calculator you want to use for A-level. There's some more advanced things that are cool, but the 991EX, I think it's a good, solid machine that will do the job really well. You got to have one at a minimum. Any other the other calculators that might have got you through GCSE, no. Can't use them for A-level. It's going to get you stuck. And for this one, as soon as you write this down, you just want to solve it using the solver on the 991EX. But there is a catch. State the formula. So you would write down minus b squared plus 4ac. You write down the whole thing plus or minus the square root of b squared 4ac. You write the whole thing down. and you'll do the substitution. You're not using the formula to do the solving, you're using the calculator, but you got to show evidence. That's really important. There's a lot of questions that you'll see where they'll ask you to show, and writing down the formula and doing the substitution is important. Now, in this case, to be honest with you, you could use the calculator to get the answer, but this one is actually just easy to factorize, so you can just factorize it. That's the factorization there, which I think is a quick one to come up with, is equal to 0. So once you do the factorization, you get your double brackets, then you'll get that, well, for the first bracket is equal to 0, that means y is a half. The second one, y is equal to 8. Okay, so those are your two y values. And if you use the 991EX, those are the values you would get. All right. If you have it, but you're not clear on how to use it to solve, I'll do videos on that at a later stage, or and we'll sort that out for you. But because it's one thing to have it, it's another thing to be able to use it. Yeah, and we want that to happen. Right, let's go on. We found the y values, but we were not asked to solve 2y squared minus 17y plus 8. So we got to go back to what we were actually asked to solve, and we know y is 2 to the power of x, so that means that when y is a half, it's actually saying what we actually worked out is 2 to the power x is a half. And you have to ask yourself now, well, what power do I need to raise 2 to get to a half? And I hope you'd agree that that is going to be -1. It's the reciprocal. A half is the reciprocal, and that's 2 to the power minus 1. And then we do the same thing for 8. When y is 8, 2 to what power will give me 8? And it's 2 times 2 times 2, so x is 3. So we solved for y, but we weren't doing an equation for y. The equation we were trying to solve was in terms of x, so we get the y values, and then we use the y values to find the corresponding x values, which are the final answers to our questions. So that's a new idea, the substitution, but hopefully it all makes sense, and hopefully you think, yeah, I can do these. As I get into the A level and I'm doing more and more practice, I'm going to get my head around this, you know. Feel free to put any comments about this one in the below, and I'm happy. I'll look through, and I would reply or respond appropriately as and when I can, okay? It won't be instant, but it'll be there. Right, how we're doing? We're number 3. Number 3. Right, number 3, it's a small one here, similar to the previous one, you know? So a chance to, if you weren't successful in the previous question with that manipulation of the algebraic power, hopefully by what I did just now, you can do it. So use the power of the pause the video, and what is y? Okay. Now this one is a little bit different. It's not identical, because the thing is we want 2 to the power of y, and well, you have 8 to the power. So what's the first thing you need to do? First thing you need to do is change the 8 to a power of 2. So similar to what I did when I was doing some manipulation for the y to 2 to the power x. Yeah, I did something like that, kind of. Right, so 8 is 2 to the power 3. So the first thing you'll do is substitute 8 for the 2 to the power 3, and that means that 8 to the power 2x plus 3 is actually 2 to the power 3. Note it goes in brackets, 2 to the power 3 raised to the power 2x plus 3. And note it goes in brackets. What does that mean? For brackets, what's the rule for powers? It's to multiply. So this 2 to the power 3 to the power 2x plus 3, the 3 gets multiplied by the 2x plus 3. What we have is, and I should have done it in brackets, but I just went in ahead and expanded it actually here. So we're going to multiply the powers, because with brackets we multiply the powers, and I have multiplying the powers, expanded the brackets. I have 3 lots of 2x, which will be 6x, and 3 lots of 3, which would be 9. I would confirm, I thought I put it in here, but I didn't. I would confirm that if you, so actually, let's just finish this. The final answer, actually, yeah, that's fine. The final answer you want to write, I didn't write it in. Can I put it in here? I should have written it down. Stating y in terms of x, I'll do the job where you can write y is equal to 6x plus 9. Just for the avoidance of doubt, if you have 3 brackets 2x plus 3, you would get the credit for that. They just said to state y in terms of x. Nobody said to expand what format, with or without brackets or anything like that, expanding and simplifying, so you don't have to. I actually found it easier to go direct, but 2x plus 3 in brackets is an acceptable answer, okay? Good stuff there. Hope you're feeling good. Hope you've had a lot of success. And for what you haven't had success, you're looking at it or you go back and play it. That's the power of video. You can go back and look at it and you're like, yeah, I get what's happening here. I get what's happening here. Number four. 2 questions. It's I did it prettier than this. I don't know why they're not evenly spaced. What's going on there? But got the line down the middle. The first one, 32 to the power 3/5. This is like that first one, part A. That's like straight out of a GCSE 2 marker. Yeah, it's straight out of a GCSE book. But is it the kind of thing you were getting right previously, or is it something you need to work on? What does it mean, the power of 3/5? Well, it means the 5th root of 32 cubed. So I find the 5th root, the denominator is the root, and then I raise it to the power 3. Power 3 is cubed. So it looks like this. What number do you multiply? What number do you write down 5 times to get 32? Well, write it down 5 times and multiply to get 32. And that's going to be 2, isn't it? So you want to cube 2. It's going to be 2 cubed. It's going to be 8. That's the answer there. Hopefully that makes sense. That's all good. And then for the second bit, simplify fully. We got an expression in brackets, and then that is being raised to the power -1/2. So let's focus on that -1/2. What does negative to the power -1/2 mean? And I always say to work anti-clockwise, and the denominator is the root, so I want the second root, the square root. Then the top number is so square root, then the power of 1, so power 1, no effect, it doesn't do anything. And then there's a minus sign. It was really small to see, but it was there. A minus sign, which means you want the reciprocal. Now, that's the order I'm going to do it in. You might have messed. Some people decide to do the reverse of the reciprocal, so invert first. And if you want to invert first, that's fine. But I just work anti-clockwise. So what does it mean? It means we want the reciprocal of 5x squared on 2. How did I come up with that? Well, I've applied the first 2 effects, the first 2 operations. Square root, you square root the numerator, you square root the denominator. Square root of 4 is 2. The square root of 25x to the power 4, you can split it. Square root of the number, square root of 25 is 5. Square root of x to the power 4 is x squared. X squared times x squared, add the powers, you get x to the power 4. So the square root of 25x to the power 4 is 5x squared. So we have dealt with the square root, and raising to the power 1, anything to the power 1 is itself. So after doing the 2 steps, square root and first power, we still have 5x squared on 2. And the last bit is the negative sign, which is not to put a minus sign in front. It indicates we want the reciprocal of the value. So the reciprocal means to invert, and we get 2 on 5x squared as the final answer. 2 on 5x squared. Okay. If you wanted to write it as 2/5 x to the power -2, that would be okay. Yeah, your choice there. Okay. So that's number 4. Now to number 5. Number 5. Yeah, right. So this one, rationalizing the denominator, but a little bit more complex. Hopefully you've seen some of these once or twice when you were doing GCSE. But it's, yeah, or you might have seen something easier, but it's the same idea that applies. What is the idea that applies? Well, we want to choose the multiplier to rationalize the denominator. So what can I multiply this fraction by that will turn that root 12 take away root 8 into an integer? That's what we want. And the master plan in this particular context is to use the concept of difference of 2 squares. Okay, so if I was, in other words, if I was to set my multiplier, all I'm doing is changing the sign, because what's going to happen is when we multiply, so let me just go, we're going to have these double brackets. When we do the multiplication, the top is going to be double the root 12 plus 8. We'll deal with the numerator after. It's the denominator. We want to rationalize the denominator. That's the only way we're going to get no denominator, because that's the format we want here. Difference of 2 squares. Square root take away square root by square root plus square root will give you the number squared take away the first number squared take away the second number squared. In other words, what do you have here? You just have this. When you expand it, you're just going to get 12 take away 8. The middle terms cancel each other out because of the change in sign. you're going to get a minus root 8 root 12, and then you'll get a plus root 8 root 12. You go on and do it if you so satisfy yourself that that is the case. And that's your strategy. Anytime you have two terms in your denominator and you want to rationalize, keep the two terms but switch the sign. If it's add, go with a denominator that's plus. And remember, we're just changing the format of the number, not the value. That's why the numerator and denominator have to be the same, because we're multiplying by 1. That's what this is. That's just 1. Multiplying by 1 doesn't change the value, but by careful choice of how you represent 1, you can change the form of the number. And that's what we're trying to do, change the form, not the value. What we end up with an answer, as the answer has the same value as what we originally started with. From here, we can work through, and we're going to get 4 in the denominator, and now we can focus on the numerator. And the format suggests that the denominator, everything's going to cancel out. So I need to, so in other words, I need a 4 in the numerator, 4 divided by 4 to give me 1. That's what I'm thinking about. And this is where simplifying the thirds come in. What's the biggest square number? Well, how can you factorize root 12, root 8? Square numbers they have in common, and you can hopefully you realize that 4 is a common factor for 12 and 8. So root 4 is a common factor for root 12 and root 8. And root 4 is? Exactly, root 4 is 2. So we can factorize. It's the same common factor, so I can rewrite it factorized, and you can see, I mean, it's job done. I'm making it as explicit as I can, but hopefully you see where we're going here. Root 4 is a common factor, and root 4 is 2, and 2 times 2 gives me, that's 4 in my numerator, which is what we wanted. 4 divided by 4 is going to give me 1. All we're going to be left with is the root 3 on the root 2, aren't we? That's what happens here. 4, and we get root 3 on root 2, a, which fits into the format they wanted. A and b are integers. They're two different integers. Okay. Is this one you're going to work on more on? I think it's probably one you'll want to do more on, but do let me know. In the first few weeks when you actually start the course, you're going to get a lot of practice on these. You'll probably have to do a full exercise, a fair amount of these. But if you do it before and you're expert before, it just makes everything easier, yeah? Makes everything easier. So there you go. There you go. Final one for this session, and I'm managing to, I'll keep it under 30 even with my explanations. I'm talking through, not just doing. It takes time. The first one, I'll be honest with you, I think the original version of this, there was supposed to be a minus sign, but you can't see anything. It just looks like 16 to the power a quarter, which, any problems on that? Hope not, hope not. It's the fourth root of 16, and the fourth root of 16 is 2. If it had the negative sign, then it's just going to be, negative sign means reciprocal, so you'll have a half, okay? But it doesn't have the negative sign, so we're good there. And then finally, B is a bit, this is more interesting. I like this one. I hope you enjoyed it, or if you're not sure how to do it, and as we go through it, you'll think, oh, that's cool. I like this, okay? Right, so we have the x. And really, we need to work on that 2x to the power negative a quarter to the power 4. And remember, multiplying, you multiply by the powers. And to deal with these, you got to separate them, because it's a number to the power, and then the x expression to the x term to the power. So what we have is 2 to the power of 4. And then we have x to the power negative a quarter to the power 4. So the number to the power, the x term to the power, if there was another term, a y term to the power, you split it. That's how we work on these. And this with the negative, the quarter, it's a bit funny there, but you know what I mean. And at this stage, we can work it out. 2 to the power 4 is 16. So the first piece is 16x, isn't it? And now we need to focus on the x to the power negative a quarter to the power 4. And the negative a quarter to the power 4, there's brackets, so we got to multiply the powers. What we have is negative 4 times 4, and negative a quarter times 4. And a quarter times 4 is 1, so negative a quarter times 4 is, that's right, what we have is 16x being multiplied by x to the power minus 1. And you see where this is going? Wow, we started off with x. We started off with x to the power minus a quarter. Hang on, x to the power minus 1 is divided by x. The x's cancel out. Final answer, 16. The x terms, the variable is gone. This expression doesn't matter what value of x you put in. When you simplify, you're going to get 16. Okay, really interesting one there. Hope that made sense. Hope you found this useful. Any comments, welcome at the bottom. And I look forward to working with the next thing up is going to be, so look out for the senior match challenge pack. I'll look at the first 10, maybe 12 questions, depending how straightforward I think the first 10 are. So that's going to be coming up. Just check back, check later. Check every Monday I'll put stuff out, so just check later on and you should see that if you haven't seen it already. 2015 for first 10 or 10 questions or so of the senior 2015 paper. And yeah, we'll see where we go from there. Okay, great stuff.